Hi, I'm Dr. Morbaja, astrodynamicist, space environmentalist, and associate professor of aerospace engineering and engineering mechanics at the University of Texas at Austin. And I listen to the Cold Star Project.
This show is for entertainment purposes only and is not intended to be what is termed professional advice. The Cold Star Project is proudly presented by the Operational Excellence Society. Cold Star Tech is a supporter of the OPEX Society, and Jason Kanigan is a member of its board of advisors. Talk with us at Cold Star Tech to find out more about the OPEX Society and what we can achieve together in your organization, or just visit opexsociety.org. Thanks for joining us for today's show. Today's guest is Edmund Burke. He was an Air Force program manager and project director for many years before founding his own company, Space Information Laboratories, and that was back in 2004. This is interesting. We're going to be talking about Vandenberg Air Force Base, but also at Vandenberg and Cape Canaveral. Edmund was the Space Lift Range System, Range Instrumentation, and Metric Track Lead for both those places. So he knows a lot about design of launch vehicles, missiles, small satellite avionics, and especially power systems technologies. And batteries are really important. SIL makes special kinds of batteries, and particularly power system technologies that need to be range, safety, and space environmentally qualified. Edmund, welcome. All right, Edmund. So let me ask you this question to start us off. Why did you want to book, and I know Tim Anderson helped us out, who's been a guest on the show as well, talking about SpaceX. Why did you want to have this conversation? What value do you believe that is urgently needed by the space industry that we'll be able to cover here?
Well, I wanted to talk about the transition, first of all, the autonomous flight termination systems and space-based range, where you have really no ground assets anymore to track, destroy, and send high-speed telemetry from vehicles, which is a transition. That was actually the epicenter of I started Space Information Labs, and also the safety aspect of it. Like when you come up, have a new launch vehicle, and all the requirements for range safety that's required for you. It's not just the rocket itself, but it's all the many subsystems that make up the rocket that they're interested in having approvals that the hardware has been tested to certain levels. And a lot of the startups, they don't really fully understand or appreciate what it takes to do that. So it ends up delaying projects by years, and so we'll talk a little bit about that. Primarily still, we design and build flight units, avionics, and batteries. And so that's what we do day in and day out. And anyway, that's the primary points I wanted to discuss.
Okay. So say I'm a 22-year-old engineer just getting out of college, getting my first job, and I happen to luck into space or defense, and I don't know anything about a shift from right, something to autonomous flight termination. Okay. So let's go back and explain those terms, or maybe even begin with what was going on before, like 20 years ago, let's say, if I went to Vandenberg.
Yeah, so when we launched a rocket to space, we had a lot of ground radars, that would track the rocket. It would basically send a RF pulse out, it would hit the vehicle, it would return, and you would get, exactly where it is relative to the center of the Earth and its velocity. So we had a series of ground radars at Vandenberg, and also at the Cape Canaveral, we had ground radars. Secondly, flight termination is done also with ground assets. You have flight termination sites, and they would range safety officer would press a button. If they looked at the screen of where the rocket was, and they also looked if it's roll, pitch, and yaw, they would press a button, and they would have these ground termination sites, or just RF links to the vehicle, and terminate the vehicle. So you had radar on the ground, you have flight termination sites on the ground, and we also have telemetry systems on the ground, which collect the telemetry data from the rocket to see what's going on, all the temperatures, the pressures, and that's pretty high speed. So there's a shift. Actually, my first patent, VBITS, was patent 5739787 in April 1998. it talked about autonomously terminating a vehicle without a man in the loop, which basically eliminates the need for radar on the ground or flight terminations ground systems. And then the holy grail is also to replace the telemetry coming down from the vehicle and go straight to a satellite with that data, which is even more difficult. It's actually right now we're having a K-band revolution in satellites, and now it's possible to do that also. So it's about efficiency, right? In the Air Force, when I first pitched it, even to NASA, I went to NASA Wallops and actually took about 6 months to get a meeting, and then they finally realized, oh yeah, this is a good idea. And actually they started working on it themselves after I left, but that's another story. But initially it was like the discussions were from no way, no, that we're not doing that. And now 20 years later, 4-star generals are saying, no, we are going this way. And by 2025, everyone must transition or no later 2030 for military systems. So something was like, hell no, we're not doing this, is now hell yes. And because it saves, it's not just the technology side, it's also saves money, operational maintenance, to maintain all these ground assets, to basically to track and destroy and send high-speed telemetry from vehicles. So there's a transition of technology, and GPS was at the epicenter of that. GPS on our phones, now you say go to, navigate to, and you get right to where you need to go. Well, we started implementing that in the late 90s and 2000s on rockets. We proved that we could track without loss of lock, and I did that on first started on DoD missiles, and then I did it on Atlas and Delta rocket for GPS tracking, and that became a way that we don't lose lock with where we're at position wise. And that's at the epicenter of autonomous flight termination. You have to know where you're at, and you cannot lose lock. If you lose lock for 1 second, then autonomous flight termination system won't work, right? So at the epicenter of that is GPS tracking and also inertial navigation systems that are on the launch vehicles. That's what flies yourself to orbit. So those two sensors, if you can rely on them, then you can autonomously terminate a vehicle. And that's what technology that we're working on. So that's a brief summary of the transition that's happening now.
Okay. And when we say flight termination systems, let's describe what that is. Are we talking about, okay, boom, or it just falls to the ground?
Yeah, it's an actual termination where the person, the range safety officer, determines on a screen it's off trajectory, and they also look down at the strip chart recorded to the right, and they see if the vehicle's roll, pitch, and yawing. And if it's off course and it's rolling and pitching when it shouldn't, then the range safety officer makes a decision to press a button. It sends a command to the vehicle, and there's called a flight termination receivers that receive that command, and then it then goes to the ordnance on the vehicle. There's ordnance that actually splits the vehicle in half and basically stops it from continuing. Or it may rip itself apart before even that happens if the vehicle's off course, and it would be, normally the vehicle starts ripping itself apart, because if you're going that fast and you start veering off or rolling, it kind of, the atmosphere takes it out. But they want to make sure to terminate, and it could be coming off the pad too, just 5-10 seconds after launch, and start pitching over, or start heading in, like, we launched from Vandenberg. If it comes off the pad and starts going inland, immediately towards Lompoc, you got to take it down. You got to terminate it the first 10 seconds.
Right.
So unless it hit, you don't want to hit in a city. If it can make orbit, the launch vehicle, it can hit any city in the United States or the world. Okay. So you have to have positive control to terminate the vehicle. And that's range safety's job. Primarily job is safety of life, which is first priority, safety of life and property. They don't want to hurt life first or property, right?
Right.
And you
So
see the Chinese actually
they
have
don't
had
care so much about that.
exactly right.
Knocking down their own villages.
Yeah.
So is there anything left to recover that's useful once the flight has been terminated for inspection?
Not much. I
Yeah.
mean, a lot of the times it lands in the ocean,
Mm.
but
Mm.
sometimes they do go off the pad and tilt over, and it doesn't. The engines fail or something, and then it
Mm-hmm.
usually terminates and hits the ground. So I mean, they go out there in those cases. They go out there and try to like get the pieces to
Mm-hmm.
if to try to figure out root cause of
Yep.
why it happened. I mean, the main thing is, in launch vehicle providers, you have to be collecting this data because if you have a good day, that's great. You make orbit, nothing
Mm-hmm.
happens. But if you have a bad day and you don't make orbit, then all the data from the telemetry systems and the tracking systems and everything coming down is then that's the only thing you have to try to piece together what actually happened. And if you don't get that data, then they may not let you fly, okay, until you find root cause. So it may delay your programs for years if you can't tell them like, well, what happened.
Right.
So that's a big part of. So you have to think through that too.
Mm-hmm.
On when you're a launch vehicle provider.
All right. Who is in a position to request access to Vandenberg? At what point do you have to be at before you can submit some sort of paperwork or application to be able to fly on the range?
Yeah, you have to go through a process. There's called a front door to Cape Canaveral or Vandenberg. It's usually the plans and programs office. I'm not sure what it's called today, but it's plans and programs.
Yep.
And you go in there and you say, hey, I'm a commercial launch vehicle, and they then start talking to you, and then you have to submit a certain documents to them for just to get in the door,
Mhm.
to describe your vehicle and the basics of your vehicle and all that. And then you get deeper and you get into the range safety office, and that's when you have to start submitting your system designs of your vehicle and what subsystems are there and the requirements. There's these documents called Range Commanders Council. RCC 319 is a document for all flight termination systems, which is basically describes how you test flight termination systems. And then you have 32401, which is more of avionics. And flight termination systems, not only the flight termination unit, but you also have batteries, flight termination batteries that power the flight termination systems. So there's these guidelines that they give you, and you must follow them the way you test. The FAA, by the way, is also they're adopting through FAA guidance these documents now. They're actually copied range safety documents, and when you go through them now, it used to be like when Elon Musk started, he didn't have all that. Wasn't that well documented through the FAA, so he kind of got
Yeah,
I
hand
wouldn't say a
waved.
free
Yeah.
pass, but he did get scrutinized. But now they're writing it down more through the FAA because at that time the FAA had no commercial launch vehicles.
Mm-hmm.
Now there's like 5 or 7 that are viable or that are really going to be showing up at FAA and also the ranges. Before, the ranges were like, if you worked mostly with DoD, the FAA, because the only offices that had range safety were the offices at Vandenberg and Cape Canaveral and some of the other Department of Defense ranges. So the FAA said, well, if you go through them and you did all the testing through them and you show us that, we'll approve you. Okay. But now the FAA office has their own range safety, and have their own people looking at this stuff now, which was about 10 years ago that transition started. And now it's fully on where you have the FAA commercial space office that you have to go through. And they're writing down more of the procedures, and a lot of what the military does, they kind of took that, okay, and established their own safety offices.
Okay.
Through them. So it's actually just in the last 5 or so years that transition's happening now fully.
Okay. I was poking fun at the 22-year-old engineering graduates. Let's poke fun at the 46-year-old operational excellence guy. who doesn't know nothing about nothing either in this area. So what, you've been participating and observing, you have worked at these places at Vandenberg and Cape Canaveral. What have you seen as far as the maturity or readiness of folks who come in wanting to fly? What level have they been at, and what kind of a gap do you typically see?
Yeah, what happens, a lot of the new startup launch vehicle companies, they learn the hard way, but what happens is they may have their rockets, one thing, their engine, their core structures, but all the subsystems, rockets made up of batteries, avionics, inertial navigation systems, part of the avionics. You have flight termination systems, either use standard flight termination or autonomous flight termination. You have S-band downlink that comes down to the ground for telemetry, mainly S-band from the launch vehicle. All those subsystems have to be tested to either RCC 319 for flight termination systems and batteries for that, or 32401. So, and it's very specific of what you have to do. Like you have to go through qualification testing. You have to do certain thermal cycles, like 24 cycle 2-hour dwells. You have to have a certain amount of vibration, shock, mil standard EMI, EMC, which is because when you put these boxes, you have radiative and conductive emissions, because you have a lot of boxes on the vehicle. So they have to work in a kind of a nasty environment, EMI environment, electromagnetic interference environment. So they make you test all this stuff. The thing with small launch vehicle company, they've never launched before, and they don't know their environment. They don't even know the environment. They try to model the environment of a launch vehicle, and they kind of have a notion, but until they fly once, they try to make measurements. So you have to, what happens is, if the units that you pick, or if you try to do everything yourself, like you try to design your own avionics, your own batteries, your own, and you do all that, and you have no heritage or no test data, the range goes, hey, what's your launch vehicle vibration level? What is, when your two stages come apart, what's the shock level? And they start asking you, well, has that box been qualified to show that it can work in that environment? And if you didn't, a lot of the people don't understand the detail of all this, and they make choices early on, and then the range safety goes, no, your box, it was only qualified to 10 GRMS, and your vehicle's at 16. So by the way, you can't fly that box. You're going to have to do a Delta qualification on that box, and that takes up to 6 months to a year, and that delays your vehicle. So what I see is, a lot of times, launch vehicle providers, because they have investors, and they always promise, oh, I'm launching next year. And then next year comes, and it's next year, and next year, and next year. And that happened across all the ones that started up. From the time they thought they could launch to the first launch is usually like 5 years from what they originally said, or maybe up to 10 in some cases.
The venture capitalists, listen up.
So
it's an important factor here for you.
Yeah. So yeah, I mean, and that's, most people know that now. The ones that are there at the table are legitimate. They know this, but unless you lived it and you have to go there, you really have to think about the qualification and the environment that your vehicle's flying. And it's hard, because the first one, even in a DoD program, we never get the environments. Even we're building flight hardware, and we're trying to deliver this flight hardware, and a lot of times it's right to the very end you get the environment, because it's hard to predict and quantify the environment. And we always, even in DoD programs that are well established, we don't get the environment till later on. And so that becomes the dynamicists for launch vehicles, for figuring out the vibration level and the thermal environment in specific areas of the vehicle. It actually is quite a bit of effort in that regard, and it's always underestimated, and that's what delays things. Because you really haven't tested the hardware to the environment. Engineering's humbling. If you have not tested something in the environment and not just once, but many times, you always learn things.
Mm-hmm.
So that's why I always tell these launch vehicle providers, new ones, why don't you just buy some of the hardware in these certain areas from vendors that know how to do this,
Mm-hmm.
and focus on what you need to do to make your rocket happen, like your engines and everything else. But a lot of them learn lessons, and I don't want to name names, but they've learned hard lessons. You know, they saw Elon do vertical integration, and everyone goes, oh, we need to do vertical integration. Well, Elon spent about 10 years getting his first rocket. I mean, he failed 3 times, and he finally got one off. But it took him almost 10 years to get to that first successful launch. And Vandenberg Range Safety helped him a lot early on, the people at Vandenberg. So it's anyway, it's an area that I wanted to talk about, that so that some of the startups realize you have to have deep pockets is the bottom line to get through all that, get to the first launch.
Because you're going to hit the unexpected.
Yes,
No matter
you're
how
going to
much
hit
engineering you
right,
think
and you're also gonna hit sometimes where you got all the greatest hardware, and someone makes a simple mistake during qualification, and an engineer or a test person, and they have a problem in qual, and the unit fails. It may be a hookup issue or some other issue, and the unit doesn't pass, and then it delays you 6 months sometimes. You know, every subsystem has to pass. It has to be either shown that it can work in the environment or have passed. So anyway,
and going back to, you may not understand the environment fully. Hard to get it to pass when you don't understand it.
Right.
Edmund, you've mentioned batteries a couple of times here in the termination system, and that I know Space Information Labs makes lithium, battery systems. Let's talk about that for a little bit.
Sure. Yeah. I have a little demo. Here's a typical battery. This is actually a 2 amp hour flight termination system battery that we have. And then also I wanted to show you, this is a 3D printed model. I have aluminum ones back in the back that we're actually going through qual right now, but this is what it looks like. It's a small little box, and it has the brains, it has the receivers, GPS receivers, and the algorithm in it, which is provided by Range Safety, to make the decision from the sensors to destruct the rocket without any man in the loop at all. So it's all vehicle based on the vehicle. This battery powers the unit, and that box right there makes this decision to terminate the vehicle. So anyway, batteries, we're a battery manufacturer, flight termination and avionics, but the battery is, it has an advanced battery management system in the front, which you can see right here. This is a typical BMS board, and that goes in. You can see the front part. It slips underneath and goes in. But this, called an intelligent or smart batteries, we basically make it turnkey for a user. But if someone walks up with 100 volts, the battery go, nope, you're not charging me with 100 volts. So it has over voltage protection, under voltage, short circuit protection, thermal protection. Because lithium batteries, if you operate them in your environment, they're fine. But if you walk up and make a mistake, like a technician charging a battery, this is a 33.6 fully charged battery, and if you put 100 volts on it, like a power supply has 100 volts, this can charge till it blows up. But we don't let that happen. So we have all the smarts in the battery so that a technician, operator, or will not make a mistake. Or if it gets really cold, lithium batteries, like in your phone, you don't want to charge them below 0 degrees Celsius because they get lithium plating. So we don't allow you to charge in real cold temperatures. So lithium's great, but you have to, discharge and charge, and the environment has to be a certain environment. Like a lead acid battery, it doesn't have any of that, but it doesn't have the energy density of this too. Lead acid battery, you can charge it, because of acid, even your car, pretty cold.
Right.
But
now you've been providing these to clients in the military and civilian environments for how many years?
Yeah, we've been supplying batteries since mid 2000s.
Yeah, so it's been a while.
Yeah, like
they have the heritage.
15 plus years. Yeah,
what you're looking for there.
So and Yeah, you have to have flight heritage. You have to have,
Mm-hmm.
put it through testing. That's the big thing is to qualify and test it in the environment like we were
Mm-hmm.
talking about.
Right. Well, I appreciate being able to see this stuff. Um, we've talked about battery management systems. We've talked about radio interference, signal interference, and that. Radiation. What about radiation? Radiation
Yeah,
tolerance.
yeah, radiation for launch vehicles and missiles, because it's short term, you don't really have too many radiation requirements because you're done in the first 5 to 10 minutes. The mission's over. It lights and it's over. So, but when you get on a satellite now, in low Earth orbit, you get roughly 5 to 10K rad 5 to 10K radiation a year in orbit
Hmm.
level, depending on the orbit for low Earth orbit. So you have to start worrying about a single event upset like a heavy ion or galactic energy coming in and hitting a processor. So you have to design the electronics so that it doesn't upset. Single event upset, and that's there is electronics that by design can handle it by design. Those are really, really expensive. Like those are like diamond rings. They're, the chipsets like those are $25,000 to $50,000 a chip that actually can do it by design. There's a lot of other people work on commercial radiation tolerant where they use error correction, where they actually have triple voting logic and they have error correction and they correct when they see errors. And there's different techniques to do that. So anytime you're on a satellite or spacecraft or something that's going deep space, or through the Van Allen belts to the moon or out deeper in space, then you have to worry about radiation tolerance. Um, the geosynchronous satellites, they're up 22,000 miles. They're If you're up for like 22 years, some of the stuff that's up there a long time, they say, hey, everything's got to be designed at 300K rad.
Hmm.
For low Earth orbit, if you're in orbit for 5 years, people start talking, hey, 50K rad, 10-year orbit, 100K rad. So the electronics have to be designed for that level of radiation. So
Okay.
that's when all that comes in. Launch vehicles and missiles, not normally a factor.
Mm-hmm.
They
Okay.
do specify, but it's not as hard to meet the radiation on launch vehicle and missile application.
Hmm. All right. Well, I would like to hear, for one, a story or two about, well, failure stories of trying to get on the range, or maybe they proceeded a little bit and it stopped dead in the process without naming names. Obviously, not interested in embarrassing anybody, but hearing some details about what actually happened, and maybe that'll help people look for that so that they don't stub their toe on this thing and it costs them 6 months or a year or whatever.
Yeah, I mean, I think I can globally say every subsystem, batteries, avionics, electronic safe and arm devices that are on, um, GPS tracking units, autonomous flight termination, which is just now getting started. But every one of the subsystems of launch vehicles, either Department of Defense or commercial, have had issues with
Mm-hmm.
some subsystem on their first launch, or even if they've launched multiple times, they've had failures at the subsystem level that they've had to overcome and rectify. It's actually, it's not talked about, but it's almost every time there's something that happens.
Yeah, this is something I've noticed, Evan, especially over the last couple of years. A lot of launch and space companies want to hide failure. They want to look perfect, as
Right.
if they rolled this thing out and there were never any problems, right? And
Yeah.
I don't know. Coming from the manufacturing world at large, I cannot look at that with a straight face, right? I'm
Right.
always like, come on, guys, tell us
Yeah.
the truth. What is the downside of showing that you have had failures? Is it perceived as weakness, do you think, or like, oh, I
Yeah,
wouldn't want that, is there some kind of scarlet letter that goes with this or what?
yeah. In the Department of Defense world, I mean, the stuff we build, it's well known. We have failure review boards,
Hmm.
and when we have a problem, it's embraced, and we basically go through and find root cause
Hmm.
of why the failure happened.
Yeah.
And engineers do their very best, and it's usually some simple thing, or it could be a component that has a problem. And so it's not looked upon not favorable in Department of Defense. But I think in a commercial world, because you have investors, right?
Mm.
They're promising a certain time to launch, and there's certain time that they're going to spool up and be launching 10 or 15 times a year, and they have some business
Mm.
plan where you have a certain amount of payloads that you're going to launch, and you're paying customers,
Mm.
and they get into this thing where
Mm.
you got to launch at this time, and the investors are looking. It's like, look, are you going to make money and bring money and revenue in? And then you get into this game of fabrication of the truth,
Mm.
and you things slip to the right, and it's like year after year they show up at a conference, and yeah, we're launching next year, and the next year I hear the
Mm.
same thing, we're launching next year, and then the next year. And luckily some of them, a lot, if it was an investor, I mean, the investors, if they're just into making money, the space launch business, vehicle business, is probably not the best place to
Yeah.
make money at,
Yeah.
in my opinion, but who knows. But um, you, they have to be an investor who truly believes in that, whatever that company's doing, and be in it for the long term. If there's an investor, it is not, if you're doing launch vehicles, especially, satellites are a little bit different because it's just a satellite, and you can, but if you're in a launch vehicle, the investor better be into it long term,
Hmm.
else you're
Yeah.
they're going to pull out on you. And
Right.
it's going to be, and there's a lot of things online, all the ones that have, there's bankruptcies that have come out of bankruptcy, and have restarted, and they've learned a few lessons, like, let's try not to do everything ourselves, vertically integrated. I still see a lot of them want vertical integrated. A lot of companies still push that. Some of the other ones have learned, hey, it's great to be vertically integrated in things we need to do, but let's offload some of the other
Hmm.
subsystems to people that know what they're doing, and just buy it,
Right.
purchase it, right? So there's a trade-off there, but I think it's a lot of just investors, and not the investors not pulling out their money, right?
Yeah, this really highlights the value of a Raphael Roentgen or a Michael Mealing or another venture capitalist who actually knows the space industry,
Yeah,
because they worked in it, and then go to invest in it, because they'll raise an eyebrow at some of these targets and have a little talk, right, with the founders.
right,
Whereas the folks who are, as Michael would say, investing my magazine, oh, that looks good. I'm going to invest in this launch company. And I get calls, from investors from outside the space industry, and they know a few company names, and that's it. The
right,
level of knowledge is not high. And so I see how they could be not fooled, but enticed into, an idea with fairly unrealistic targets, very
yeah,
aggressive targets, right? Which, because they don't know, they have no knowledge of or experience of what it's going to take to get this thing done. So when you
right,
say, hey guys, and I agree with this in full, out in the rest of the world as well, beyond space,
right,
be clear on what you are excellent at and what you're really good at, where the value that you provide is coming from. That's the
right,
apex of your pyramid, right? And
right,
then the
right,
rest of it, dole out some money, buy the expertise, and that will speed you up. And it will
right,
also, as you say, kind of give you a breather. It'll take the weight off of, oh my gosh, I have to figure out all this stuff. Now, it's true that you will have to tinker with your design probably so that you can integrate their stuff, right? And that's a little different than designing it yourself. I can
right,
see a case for that there, but it's slower, right?
yeah,
I think it's faster to just buy the expertise, plug the thing in, design it so that it plugs in, and get on with
right,
it.
yeah.
Have we missed anything that you wanted to mention, Edmund?
um I think we covered most of the, you know um most of the areas. um there's a lot of lessons learned.
Mm-hmm.
when you're designing things, when you're building flight units. We like I said before, the engineers design do real good, but you then get to test it, and we've learned years later, we find little things that we find that, oh wow, this we didn't truly understand after building it and testing it for years. You have to be able to, in the launch business, you have to be able to build things reliably year after year after year, and it has to work, right? But a lot of things are simple. It's like electromechanical interfaces. You do everything in CAD until you build it. You don't really see something, uh, and then you catch some basic thing on how to assemble something that's not quite perfect, or you learn something during test that you didn't expect. So anyway, that's a lot of the things that we learn. It's a lot of things, lessons learned, and so, and I see this over and over. And I tell my engineers, just step back and think about the environment that this thing's in, and simple things like, yeah, that wire will break off. The whole box twists when you have high shock and vibration. Well, you need to strap that wire down. You need to tie it to something. It's usually common sense stuff. If you just step back for 1 minute and think about, put yourself in that environment, and we would probably figure out how to build something that would survive it.
Right. Okay. Well, I think it's been a great conversation. I've learned a lot. What kind of person, founder, purchaser would you like to be reaching out to Space Information Labs and talking to you?
Well, a lot of the the commercial launch vehicle companies, they're starting to find out about our technology, and they are coming to us, and they are starting to partner. We'd like to get out further to partner with others, with the message like, don't do everything yourself, in certain areas.
Okay.
Partner with people other small businesses that are experts in certain areas. So we're going to probably start up, Tim and I, Anderson, we're going to start up a seminar series on our batteries and flight termination, and then try to go one-on-one with some of the new commercial launch vehicle providers, and see if we can find a way where they'll utilize our technology, and instead of trying to do everything themselves from ground floor, or and there's a handful of companies that compete with us, and that's great. There needs to be a supply chain of at least a handful of companies that are providing different subsystems to these people, and we think we're the best of class in our battery technology and our autonomous flight, because we put the rigor and detail and testing in that's required to be successful. But fair and open competition is good too. Never lose with that, either to government or commercially.
Right. All right, Edmund. So our message to founders and engineers listening: look, if you want to fulfill your promise, especially if you have the pressure of investors breathing down your neck, right,
Yeah,
and performance standards and that kind of thing, you can get to launch and orbit faster by getting these right partners who have the experience on board and using what they've got, and just plugging that into your system.
Right.
All right. Well, I appreciate you doing this, Edmund. Where can people find more about SIL?
Yeah, you can go to our website, www.spaceinformationlabs.com. Tim Anderson, who's R&D project manager and BD manager with me, I'm the CEO of the company. You can always reach out to us. You can reach me. I just say, I'll just give sales@spaceinformationlabs.com. It goes right to me and Tim Anderson. So we'll contact you that way, or you can call our number too. We have extension here. Just call 805-925-9010, and then you'll just put in Tim Anderson or Edmund Burke, and into the phone, and it'll then dial our number here at work here on our phone. So
great. Well, thanks for sharing your experience with us. Thanks for listening to our discussion. Remember, if you're looking for the right kind of power equipment that is range safety and space environmentally qualified, go check out Space Information Laboratories. And also, if you are looking to get to launch and orbit faster by choosing the right partners with the right experience, consider talking to us at Cold Star Tech. We may not have the items, the products, or even the expertise necessarily, but I'll bet you we know who does. And so it's a great place to start. Thanks for listening, and I'll see you next time.